I just want to refresh. I don't know if I've told you guys. Okay. Starting today, because this is like the first day I've seen you of the new 9 weeks, you are only allowed to do 2 reassessments per class per 9 weeks. Okay, that's new. So that's what I'm telling you. They actually just told me that we can give you a maximum of 100 though. So instead of that 90, we can give you 100. Okay. And then the next one I've already been doing, but I want to remind you, any exam or project grade can replace a low quiz grade as long as it's in that same unit. Okay. All right. Here's the big one that I'm going to be more strict on. Late work will only be accepted before the exam on that unit. So once we've tested on the unit, you can't go back to that late work. Because I've been grading way too much late work, okay? The other thing that we're getting more strict on, especially in Algebra 2, is the exam time limits. There are some that should not be taking as long as they are, okay? So we will be setting time limits for each exam will have its own different time limit, but we're going to let you know what that is, and then we're going to follow that more strict, okay? No cell phones out unless you've asked. I've been seeing too much cell phone action and not enough notes and things like that, okay? And then please don't use your phone as a calculator, okay? Use the calculator that's given to you on your Chromebook, or you can bring your own, okay? Okay. So just letting you know, I'm getting a little more strict on some of these, okay? All right, if you go to Google Classroom, you will see that I have posted all of Unit 3. I know it says Unit 2, but we reorder our units sometimes. All of Unit 3, the entire packet is online, okay? It gives you a rough estimate of the timeline we're doing. That's always subject to change, just so you know, but it is on there, okay? And so we're starting right here on page, well, it's page 4 of the packet, but page 1 of notes today, okay? So we are going to start with this. We're getting through everything up to homework 1, so that way you can work on homework 1 today. So some of these, I'm going to start asking you, they're going to sound familiar from Algebra 1. And so I'm going to get into it. So the first thing I want to talk about is relations, right? Relations versus functions is what we're going to be talking about. So question, if you have a set of ordered pairs, you have an X and a comma Y, where could you have gotten those points? There are 4 places we could get those points from. And that's where we're filling in the blanks right now. A graph, good, that's one answer. A table, that's 2. You can, you don't have to, or you can just write them down. What did you say? No, that's kind of a graph. So I heard graph, a table. One more that I feel like you should know. The other one you might have forgotten. It can be expressed as a what? The last line, actually. Map. Okay, that's actually the one I didn't think you were going to get. Mapping. Where else do you think I could get points from? Well, that's what we're getting out of it. Yeah. Anyone online too can answer. So we have a set of ordered pairs can be shown as a table, a graph, mapping, or expressed as a what? How do you graph something? What do you usually have? Okay, if you aren't given the points, you might have been given something else to graph. An equation. Woo, there we go. I knew you'd get it. All right. So that's the 4 fill in the blanks. A table, a graph, mapping, or expressed as an equation. Okay, these are just places that we can find ordered pairs. All right, out of the ordered pairs, the x values are called something. Domain, good. So the y values are called range. See, you guys know this. All right, the next part's the harder part. A relation with distinct points. Okay, that means the points aren't connected. They're just given points, maybe like a scatter plot or something. There's actually a name for that kind of graph. Does anyone remember? It's from Algebra 1, but it starts with a D, just like distinct. No? What is it?
This is there's I after the D.
There is an I after the D. Huh?
Is there an S after the I?
Just say it.
Discrete.
Discrete. You were getting there. Good. All right, so discrete. So if you have distinct points, it's called discrete. Okay? Now, what about a relation with connected lines or points? So if they're actually connected. And I always think of connected, and then this word also starts with a C. That's how I always remembered it. No. So if I have a graph with points, but this time all those points are connected, and maybe they make a line or a curve. So we're including points or including things in between points. Does that help?
It starts with a C.
Starts with a C. Anybody online think they have it? Sometimes arrows are involved on your graph. All right, continuous. Okay. And that's because if I'm connecting points, right? So let's say I connect just a normal number line, 1 to 2. Aren't there a bunch of decimals in between 1 and 2? Yeah. And so I'm continuously all those points in between also. Okay. All right, so relations have these and functions also have these. But then we have to go, okay, well, what sets us aside from something being a function and something just being a relation? Okay, now functions can have relationships, right? But sometimes not all these relations are a function. So does anyone know how to tell the difference between something that is a function and something that's not a function? Okay, there might have been a couple ways Algebra 1 went about it. The first one I can think of, they sometimes called it the pencil test. Its real name is the vertical line test. So if you hold your pencil vertically and you put it up against a graph, if it touches your pencil twice, it's not a function. Good. Or you can draw a line, and if it touches that line twice, it's not a function. What would make it touch it twice? Like, what rule do you think would make it touch twice as a vertical? Not necessarily, because you can have a parabola and it slowly gets wider so it won't touch. Okay, so think of a vertical line. What do they share? What does a vertical line share? If I were to just create a vertical line, something is the same on everything. if I look at a coordinate graph and you put a vertical line,
They have the same axis.
they all have the same x's. That's exactly right. They all have the same x's, okay? And so for it to be a function, it cannot share an x, okay? Exactly. For every one input, it has exactly one output. Okay, so in Algebra 1, I used to tell a silly story. My silly story was, you have a best friend, right? And you would never share an X. That's just gross. It's not functionable. Okay? Nobody wants sloppy seconds. All right, so it's not functionable to share an X, okay? Let's just say it that way.
Wait, so there can't be two lines coming from one X? What?
There can't be, so if you have coordinate points, there cannot be two X's that are the same with two different Y values.
Oh, okay.
Okay. Now, the other way around is okay. I can have different X values that share the same Y. Okay. So let me show you an example. Okay. So for example, I've got a bunch of coordinate points right here. Under the function, you'll notice none of the X values are the same, right? They all have different X values. Under my example of not a function, you'll see that 6 is used twice. So I have 6 comma -1 and I have 6 comma 2. That is not a function because that input produced two outputs that are different. Okay, so that's the example. And then we talked about the vertical line test. But here's an example we can show you on the graph. So if I have a line, just a plain old like y equals mx plus b kind of line, right? And I put my pencil anywhere on this line, it will never hit my pencil twice while it's vertical, right? But if I do that on a circle, what do you notice? Yeah, it hits twice, right? So it hits once here and once here if my pencil was right here. And so a circle is not a function. All right, let's look at a couple more examples real quick. Okay, so we want to see if something is a relation or if it's an actual function. If it's a function, like you said, it's every input has one output, okay? So if I look at these points that are given on number 1, I can pull out the X values, right? Those X values are my domain. So my X values are going to be -1, 0, 4, and 6. So that's my domain. This is a discrete graph, meaning it's specifically those points. There's nothing in between it, right? That's why the domain is got the parentheses with just those numbers in it. If it was continuous, we would have something like X is greater than or equal to 5, right? A continuous kind of thing. In this case, it's discrete. And so it's just a list. You just make a list. The range in number 1 is -9, -5, -2, and 3. Okay? You'll notice I wrote it from least to greatest. That's the correct way to do it. Okay? So are the X's shared? Is it used more than once? No. So the answer is yes, this is a function. Whereas number 2, I've got all these points up here. I'm going to write the domain. I've got 5, -3, 5, and 8. Which one was used twice? 5. So when I write the domain, I'm not going to put 5 twice. Does that make sense? I'm just going to say -3, 5, 8. You don't write the number twice. But you need to know that it was used twice because we now know that's not a function because the x was used twice. The range are all the numbers. So it was -6, 0, 2, and 4. Does everyone see where those numbers came from? Yeah. Okay. And you understand that you don't write it twice. Even if it shows up twice, you don't write it twice. Least to greatest when you write it. Mm-hmm. All right, so that's if you're given some coordinate points, right? What if I'm given a table? Same idea. It's actually kind of easier in my opinion because they're listed right there. All your x values are right there. You've got -4, 0, 2, and 7. And then my y values, the smallest one is -8, and then I have -3. I'm sorry, -1, and then I have 3, 3. But do I need to write the 3 twice? No, I just need to write it once. Where was a number repeated? Was it my x's or my y's?
Oh, your Y.
Is that okay?
Yes.
Yep, we've got a function. The y can be repeated. It's just the x. Don't share an x. Okay? Y's are okay to share. I don't. I need to print more. All right, number 4 is very similar. So I'm going to actually go to the graph. Let's go to the graphs. Oh, mapping. Mapping is the other one. Okay, so mapping, we don't see mapping too often. But basically, it's just got your x's in one oval and your y's in another oval, right? And it's got arrows pointing to where they belong. So if I were to write this as a coordinate point, Cameron, we'd have -4, 0, -2, 3, 5, 7, and 5, 9. Okay? So when I write the domain, it's just those x oval in the oval. So I've got -4, -2, and 5. For the y's, I've got 0, 3, 7, 9. Were any of my x's repeated?
Yes.
Yes, they were. So that is not a function. Okay, number 6. I've got x's 2, 8, 13, 17. Y's, I only have 3 of them, so something's being repeated. -4, 0, 7. Are y's allowed to be repeated though?
Yes.
Yep, so we're good. It's still a function. So these are just different ways we can represent it, okay? The last way, I don't know why, it tends to be the hardest for you guys, and that's the graph. If I have a discrete graph, you're just going to see points. So for number 7, there's only points, and they're kind of hard to see, okay? But for number 7, I've got these points here, right? And so for my x values, what points are being used? Well, I've got -3. Is -3 being used twice though?
Yes.
Yes. So we already know it's not a function, but -3 is part of the domain. Then we have one up here, which that's 0 for x. Then we've got 2 for x. And then we've got 4 for x. For the range, I always start on the bottom and work my way up because that way over here. So my lowest value is a -5. As I go up, I have a -2. As I go up, I have a -1. As I go up, I have a +1 and then a +4. Okay? So discrete graphs are just going to have a list, you guys. Just a list. Now, the ones we've been doing, really from chapter 1 even, have been continuous usually. So we've been doing domain and range for continuous. So a line, for example, is continuous. Okay, if I do my vertical line test here, I'm okay. It never touches more than once. So none of my x's are repeated. So it is a function. But the domain, what's the smallest x value and what's the largest x value? It keeps going. Negative infinity to positive infinity. Keeps going. And same with the y's. Can you find the lowest y value, or is it an arrow and it keeps going? So when that happens, we get all real numbers, or we have the fancy little r with the 2 lines, right? So this graph is continuous. All right, let's do one that's a little trickier. All right, so number 9, if I put my pencil vertically, will it touch more than once? Yes, it will. So it is not a function. Okay, so this graph is not a function. But we still can do domain and range because it's a relation. So what is the smallest x value? You might need to zoom in to see it. -4. So it actually stops here, my graph, at -4. It doesn't go any smaller. Okay? Now it goes bigger. Does it end somewhere on my x's? Yes.
For the range, since there could be multiple y's, do you only write y one time? Like, to get 2 10s, would you only write 10 one time?
In the list, yeah. Okay, so does everyone see that -4 is the smallest x value, but is there a biggest x value? Or does it keep going? It keeps going. So in this case, my domain would be written as x is greater than or equal to -4. Or you could have wrote -4, comma, infinity, if you wanted interval notation, right? We've learned interval notation now. But my range, I can't find the smallest y value or the largest y because it keeps going. And so that one is all real numbers. All right, the last one, pay attention because there's one on your homework that people were asking about. How do you write domain and range for something like a circle, right? You still write it the same way. What's the smallest x value? -2. What's the biggest x value? 5. So x is going to be anywhere between -2 and 5. Okay, so you can write -2 is less than or equal to x, and x is less than or equal to 5. If you did interval notation, you'd have the bracket, because it's included, you'd have bracket -2, comma 5 bracket, right? So we've gotten used to interval notation too. Now, is it a function? No.
We don't need to put like a little, I don't know if it's called, squiggly line on the side.
No, because it's continuous.
Okay.
Yep. The only time you're going to list them, that's a good question. Let me go back up. The only time you're going to list them is when they're discrete. See how these aren't connected? There's no connection. Meaning, in between these numbers are not included. But in my line, like even though, like, let's say, okay, y is 1 right here, right? But I also technically have like 1.1, 1.2. I have all those in between. Okay? That's a good question. We only list it when it's discrete. Okay, questions about how to write these? Okay, the last part is the equations. So we talked about tables, we talked about graphs, talked about mapping. Now if you're given an equation. Okay, I wrote over here, the easiest to do if you're stuck is to graph it. Okay? I've been doing it so long that I can see that this is a parabola. Negative x squared plus 3. I know that's a parabola. What does the negative do, though, to that parabola? It what?
Right.
No, what's the negative in the front do?
Oh,
It flips it upside down. If I have an upside down U, does my pencil ever hit twice on a vertical line? Nope, it doesn't. It gets wider and wider. So actually an upside down parabola is a function still. Okay? I know that my domain is going to keep going, but my range is the vertex down, right? And it's okay to graph these if you don't see it yet, okay? I know that number 12 is a line. The negative makes it just going a different direction, but it is a line. I know that a line is a function, as long as it's not a vertical line, right?
so with y with the next of 3 is always.
You're good. You are good, yep.
So like.
The only time you're not good is when it's x equals -1, like number 14, because that gives me a vertical line. But if it's y equals, you're good. Yes.
On the homework for like number 7, it has an arrow that's continuous and only positive. So
Number what?
So it's continuous in one direction. So what's the smallest x value for number 7? Good. So we're going to have -4. And then does it have a biggest x value? Infinity. So you can either write x comma infinity, I'm sorry, -4 comma infinity. Or if you were to actually write it, you could just say x is greater than or equal to -4. So there's 2 ways you can write it.
wait,
Is the range all real numbers?
No.
What's the smallest y value?
It's
0. Good. It is 0. The smallest y value is 0. So it's everything greater than 0.
just -4 comma,
Yes.
but you put them in.
The bracket would have a -4 and then infinity always has a parenthesis. Good. Okay, I'm going to let you guys practice these for a minute. We still have more notes, but I like that you went to the homework. That's a good idea. So I want you to try the even numbers 2, 4, 6, 8, and 10. Okay? On the homework page. You'll do the other ones like on your own, but right now in class, I want you to try those ones. That way if you have a question. Okay, I'm going to give you a few minutes to do that. They shouldn't take too long, and then we're going to move on to the next part, okay?
Document, and then